Today we learned about writing both explicit and recursive formulas for arithmetic and geometric sequences. You need to remember what the difference between the two is. So the explicit formula is going to give you any term in the sequence. If you want the 15th term, if you want the 100th term, if you want the 1000th term, it's going to automatically give it to you. And the recursive formula, it's only going to give you the next term in the sequence. So that means like if you have the 5th term, then using the recursive formula is going to give you the 6th term in the sequence. So we have some examples here for you to look at just to remember what the difference is between arithmetic and geometric. The biggest difference that's the easiest to see is that an arithmetic sequence is going to be something that is added or subtracted. So you're going to have a plus sign or a minus sign in the problem. One of the two has to be in there. Like you see in these three examples here, they're red, blue, and purple. Geometric sequence is only going to have multiplications. There's not going to be any addition or subtraction. So all three of these that you see in green, yellow, and orange, notice they all have some sort of multiplication. Another good hint that it's a geometric sequence is that there's going to be some exponents in there. So we have a pattern here where x is 1 and it gives us a second value of 45. Then it gives us another value of 2 and 15. Then we have 3 and 5 and 4 and 5/3. And we've got to decide first, is this an arithmetic or a geometric sequence? And then we're going to figure out our formulas. And then we're going to find, lastly, the 7th term of the sequence. So if we look at this, if we're trying to figure out how to get from one term to the other, well, if I'm going from 45 to 15, it's getting smaller, so I could subtract. But if you look at the difference, 45 to 15, the difference in those is 30, but 15 to 5, the difference is 10, so that's not going to be our pattern. But if we divide 45 by 15, if we divide 45 by 3, we actually get 15, and if we divide 15 by 5, we also get 3, and if we divide 5 by 3, we also get 5/3. So our pattern here is that we're dividing by 3, or dividing by 3 is the same thing as multiplying by 1/3. So our pattern is really that we're multiplying everything by 1/3. So that makes it a geometric sequence because I'm multiplying. So our recursive formula, if you need to go back and look at the formulas from your notes, you're welcome to do that. But our recursive formula is nth term equals the a sub n minus 1, which is the term right before that, times r. So all I have to do to find my formula is replace my r, because it's the only thing I really know. So my formula is going to be a sub n equals a sub n minus 1 times 1/3, because remember we were dividing by 3 every time, which is the same as multiplying by 1/3. My explicit formula is going to be a little bit different. It's going to be a sub n equals a sub 1 times r to the n minus 1 power. And I do know a little bit more information on this one. I know that a1 is my first term, which would be 45. So really my formula is going to be a sub n equals 45 times, and then r is the same as it was before. It's still my 1/3 with an exponent of n minus 1. So this would be my explicit formula. So remember, the explicit formula will find any term in the pattern. The recursive formula will only find the next term in the pattern. Lastly, I need to find a sub 7, which means that I want to find the 7th term. Like, that's what that's telling me, is we want to find the 7th term. So I have a couple options. I could keep going in this table and find the 5th, 6th, and 7th term. I could use my recursive formula to do that. Or I could use my explicit formula, because in order to use the recursive formula, I would need the term right before the 7th term, which means I would need the 6th term. I don't have the 6th term over here. So I'm going to use my explicit formula, but instead of n, I'm going to replace it with 7. So a sub 7, or the 7th term, is equal to 45 times 1/3 with an exponent of, again, instead of n, I'm going to put 7 minus 1. So you have a couple options at this point. You could put the entire formula in the calculator or in all at once, or you can do it in pieces. So if I were to do it in pieces, I would have a sub 7 equals 45 times 1/3 instead of 7 minus 1. I would do to the 6th power. And then my next step would be a sub 7 equals 45, and I would figure out what 1/3 to the 6th power is, which is actually 1 over 729. Then I would go ahead and multiply, and 45 times 1 over 729 is going to be 45 over 729, which is actually the same thing as 5 over 243. So that would be my final answer. It would be a sub 7 is going to equal 5 divided by 243. So I have another sequence. This one's presented a little bit differently. It's presented in a graph. So before I can actually decide if it's arithmetic or geometric, one of the things I can do is I can figure out what all these points are. So this first point is going to be the ordered pair 1, 3. My next point is 2, 6. My next point is 3, 9. And this one up here I'm betting is 4, 12, just because I know what the pattern is, and that seems to make sense. So listing out my points in order and in a table, I have 1, 3, 2, 6, 3, 9, and 4, 12. And I've got to figure out what the pattern is, how my x's are, or how my y's are either increasing or decreasing. Well, it looks like they're increasing because they're getting bigger. So I've got a couple options. I know that 3 times 2 is 6. 6 times 2, though, isn't 12, so that's not going to work. But 3 plus 3 is 6, and 6 plus 3 is 9, and 9 plus 3 is 12. So that tells me that this is an arithmetic sequence. It also tells me that our common difference is going to be 3. And then we can use this in our formulas to help us write both our recursive and our explicit formulas. So my recursive formula is a sub n equals a sub n minus 1 plus d. So it's saying that to find any term, I need the term before it, and then I add d every time. Well, in this particular case, d was 3, because that was my common difference. So my recursive formula would be a sub n equals a sub n minus 1 plus 3. So this would be the first part of my answer for the recursive formula. I also need to find the explicit formula. Well, my explicit formula is a sub n equals a sub 1 plus n minus 1 times d. Well, I can go ahead and fill this out, and I know a lot more information here. I know that a1, or my first term, was actually 3. And then so it'd be 3 plus n minus 1 times, and d was again 3 as it was before. So again, I'm asked to find the 7th term, so I've got a couple options. I could continue my pattern. I could go to my table here and just keep adding 3 over and over again, and that would give me my answer. Or I can use my explicit formula. Remember, the explicit formula will give you any term, and I can replace my n with 7. So it would be a sub 7 equals 3 plus, instead of n, I'm going to do 7 minus 1 times 3. And I can simplify, so a sub 7 equals 3 plus 7 minus 1 is 6 times 3. So a sub 7 equals 3 plus 6 times 3 is 18. And 3 plus 18 is going to be 21. So I would get that a sub 7 equals 21, and that would be my 7th term. So for our next problem, we are given a sub 4, so we're told that the 4th term is 15 in our sequence, and then it tells a sub n equals a sub n minus 1 plus 2. So what they're giving us here is they're telling us that if we were to list out a pattern, so I'm going to make this in a table, because anytime we see a pattern, we want to make a table. It just makes things a little bit easier for us. And we're going to find the first 6 terms of the sequence. We know the 4th term is 15. Because that's what it told us here. The 4th term was 15. And if it tells us that a sub n, so any term, is equal to the previous term, that's what a sub n minus 1 plus 2. So that means that our common difference in this problem is 2. And we also know this is an arithmetic sequence because it is being added every time. So my common difference is 2. So that means if I have the fourth term as 15 and I want to find the fifth term, I'm just going to add 2, which would be 17, sorry. And then to find the next term, again, I would add 2, and 17 plus 2 would be 19. So if I wanted to find the terms before that, I would just go backwards. Instead of adding 2, I'm going to subtract 2 each time. And eventually I'll get back to my first term. So if I subtract 2, I'm going to go back 13, then 11, and then 9. So my first term ends up being 9. So for my last term, or my last problem, I'm told that a sub 3 equals 8, or my third term is equal to 8, and that a sub n equals a sub n minus 1. So any term is equal to the term before it times 4. So we're going to find again our first 6 terms. We know that the third term is 8. So I need to find the first, second, and then the fourth, fifth, and sixth. So if I want to find the fourth term, well, this formula says that the fourth term, so I'm actually going to write this out, a sub 4 equals a sub 4 minus 1 times 4. Well, that would be 4 minus 1 would make this a sub 3 times 4. And remember, we've already done the math, and we were told that a sub 3 was 8. So really, we know that a sub 4 equals 8 times 4, which is 32. So a lot of work just to show that in order to get from one term to the next, all I'm doing is multiplying by 4. So that's what I'm going to do to find the fifth term is 32 times 4. Well, 32 times 4 is going to give me 128. And then to find the sixth term, again, I'm just going to multiply by 4. And 128 times 4 is 512. So then if I need to go find the second and the first term, I've got to go backwards. So instead of multiplying by 4, I'm going to divide by 4. And 8 divided by 4 is going to give me 2. I'm going to do that one more time, and 2 divided by 4 is going to give me 1/2. So I have now found the first 6 terms in the sequence.